Hello everyone. Welcome to the solution of LeetCode problem 1658 named minimum operation to reduce x to 0. In this problem, we are given an integer array nums and integer x. In one operation, we can either remove the leftmost or the rightmost element from the array and subtract its value from x. Note that this modifies the array for future operations. Now, we have to return the minimum number of operations to reduce x to exactly 0. And if it is impossible, we have to return -1. Now, let's understand the first example. Here, the array contains 5 elements, which is 1, 1, 4, 2, 3. And the value of x is 5. So here, if we remove these first two and these three, then the total will be 5, which is the summation. And if we subtract 5 from 5, it will become 0. Now, yes, it is one solution. We can either remove these two, 1, and these 3. Or we can simply remove these two elements, which is 2 and 3. So if we remove these two elements, 2 and 3, their summation will be 5. And in total, there are 2 elements. So we have to return 2. But in the second example, we cannot make the value x to 4. That's why we have to return -1. I hope you understood the problem statement. Now let's move on to the algorithm. Now, to solve this problem, we have taken the first example. Here, we have 5 elements, which is 1, 1, 4, 2, and 3. Now, the value of x is 5 here. So we can remove this 1, these 3, and their summation will be 5. So if we subtract 5 from 5, it will become 0. So here, in these scenarios, we can return or we can simply remove 3 of the element. Now, in another scenarios, we can remove these 3, these 2. So here we have to return 2 element, and similarly, we have to subtract 3 plus 2, which is 5 from x, and x will become 0. So in this case, we have to return or remove 2 elements. Now, can we remove the element from the middle? That means, can we remove the element 1 and 4? Obviously not, because according to the problem statement, we can simply remove the element from the beginning or from the end. And if we remove any element from any of the pointers, we have to simply shift our pointer. Now, the question is, how can we solve this problem? Now, let's rethink this problem in a reverse way. Instead, at first, let us understand what the basic intuition is. Basically, in this problem, if you have the familiarity with the prefix sum and the suffix sum, then it will be a little bit easy. Now, basically what we are saying is that in this problem, we have to find a prefix where the prefix sum and the suffix sum and their summation is equal to x. Basically, we have to find 2 of the array where the prefix sum plus suffix sum is equal to x. Basically, their summation. Now, this is the intuition. And can we solve this problem by using the sliding window technique and by utilizing this prefix sum and suffix sum concept? Yes, we can. Now, at first understand what is the summation of all of the element. So here, the summation of all of the element is 11. Okay. So if the summation of all of the element is 11 and the prefix sum and suffix sum will be equal to x, basically their summation. So what is the value presented in between? What is their summation? It will be 11 minus x, or it will be 11 minus 5, which will be 6. That means basically we are saying that the summation of this prefix sum and suffix sum array will be 5, and the summation of this middle array will be 6. Now, let's reduce the problem statement. Here, basically, we have to find the subarray which has the maximum length, where the summation will be summation of all of the element minus x. Now, if we find any of the subarray where the summation will be summation of all of the element minus x, then suppose this is our array. Now, what this array basically means, their summation will be 6. And that means we have removed this element, and this element. Their summation will be 5. So 5 plus 6, which will be 11, which is the total sum. Now, basically, we have to try to expand the sliding window as maximum as possible. Suppose for this window, their summation will be 6, which is the 11 minus 5. Now, what this window means? Because the more the size this window has, the less we have to perform the operation, or the less amount of number we have to remove the element. So now the problem is, basically, we have to determine what is the maximum window size where the summation of all of the element presented in this window is equal to 6. Basically, this is our reduced problem statement now. Now let's see how can we solve this problem by using the sliding window technique. Now, for the sliding window, we have to take 2 pointers. One is left and another is right. Now, left and right, both of them are pointing to the first element. Now, here our target is 6. Okay, so far so good. Now, the window sum will be 1. So, it is not equal to 6. Again, we have to expand our right pointer here. So, here the window sum will be 2. 1 plus 1, 2. Again, it is not equal to 6. Now, we have to expand the window here. So, their summation will be 6. So, the length will be 3 here. Now, for this window, their summation will be 8. And we have to shift our right pointer. Now our window is this, and we have to subtract 1 from it. Now it is becoming 7, which is greater than 6. Again, we have to shift our pointer, left pointer by 1. So we have to subtract 1 from 7. It will become 6. So we have found another 6 here, which is 4 and 2. So here the length will be 2. Now again, let's expand the right pointer here. So the summation will be 6 plus 3, which is 9. And 9 is definitely greater than 6. So we have to shift our pointer here and subtract 9 from 4. Sorry, subtract 4 from 9, and it will become 5. Now, as it is less than the target value 6, and the window will stop. So here, basically, we have found 2 of the window where the summation will be 6. One is this, and another is this. And this window has the size of 3. This window has the size of 2. So What is the optimal window? Here, the optimal window will be 3. Because if we take this window 3, we can simply remove these two elements. So here, the removal is minimum. That's why the answer will be the length of the array, which is 5, minus the maximum window size, which is 3, which will be 2. Okay, I hope you understood the algorithm. Now the overall time complexity of this problem is big O of n. Now let's move on to the code. In this problem, the code is pretty simple. At first, we are given a function named main operations, which is a vector and integer x as a parameter. Now, we are calculating the total sum of all of the elements in the array. And now our target sum will be total sum minus x. And we are taking two of the pointer, I and j, initialized with 0. And currently our window sum is 0 and maximum window size is 0 as well. Now here, if the target sum is 0, that means we have to remove all of the element from the array. So we have to simply return a dot size. Otherwise, if the target sum is less than 0, we cannot remove anything. So we have to return -1. Otherwise, we have to apply the sliding window mechanism here. Now, we have to run this loop till the j pointers become out of bound, and we have to add the window sum to the a of j. Now, we have to repetitively check either our window sum is greater than target sum or not. If it is, we have to subtract the ith element from the window sum and increase the I element, I pointer. Now here, if window sum is equal to target sum, we have to simply store the maximum window size, which will be the maximum of maximum window size and the window length, which is j minus I plus 1. Finally, we have to increment the j pointer. And here, if the maximum window size is not initialized with anything or it is 0, we have to return -1. Otherwise, we have to return the size of the array minus the maximum window size. I hope you understood the code. Thank you everyone for watching the video. We will get back soon with another LeetCode solution.